Hi, this is Mr. Reese, and this video is going to concern reference angles. And we're just simply going to go into the basics for this video. So what you're going to get essentially is a method for memorizing special angles, sine, cosine, and tangent for special angles, that is, and then how to apply that to angles that go beyond 90 degrees. So why don't we first start off with a chart. What you're seeing here is a chart for all the special angles. That's 30, 45, and 60. Plus we're also throwing in 0 and 90, and the reason for that is because the lowest you can go is 0 and the highest you can go is 90 for all angles. Now of course there are other angles in between, but special angles come up the most, which is why that's going to be our focus here. What we're going to do is we're going to generate a chart on our own. So if you don't have the benefit of a calculator, this is the way that you can do it by hand without having to draw triangles and figuring out opposites and adjacents and such. First of all, I've written this in the order of sine, cosine, and tangent because on most calculators they put the sine first, then the cosine, then the tangent. For the sine, I'm just going to number from 0 to 4. And the reason why we go up to 4, well, 4 quadrants, there are 4 quarters in a basketball game. You can attach whatever cultural significance you'd like to it, just go from 0 to 4. That's really it. Now, the value of sine can't go beyond 1, so what we're going to do is, since the highest number is 4 here, we're going to divide all these numbers by 4. And to finish it off, what we're going to do is we're going to take each of these fractions and we're going to square root them. That's really all there is to it. So what you have is essentially the square root of 0 on top. That'll give you 0 for the sine of 0. Here, that's the square root of 1, which is 1, over the square root of 4, which is 2. This is just simply root 2. The square root of 2 does not simplify. And then that's 2, of course. On the bottom is always 2. That's going to be root 3 over 2. This is going to be the square root of 1, which, well, you can figure that out. So these are your values for the sine. That's the sine of 0 degrees, the sine of 30 degrees, 45, 60, and 90. That's it. To generate the values for the cosine, it's the same numbers but in reverse. So put your 1 first, put your 0 last, and then all the others kind of fall in similar order. So just like that, you've got most of this chart filled out. The only thing left to do right now is for tangent. And to do tangent, all you have to remember is that the tangent is the sine over the cosine. So take all your values for the sine and then divide them for your answers for the cosine. So that's 0 over 1. In other words, 0. For 30 degrees, that's 1/2 over root 3 over 2. And what happens is when you divide these two fractions, the 2's are going to reduce out. So all you really focus on is just the numerators, 1 over root 3. Most people will take this fraction and rationalize the denominator so that it becomes root 3 over 3. As for 45, it's root 2 over root 2, which is just simply 1. As for 60 degrees, that's root 3 over 1. And last but not least, for 90 degrees, that's 1 over 0. And remember that when you divide by 0, that's simply undefined. And that's simply it. That completes your chart. Now let's get to special angles beyond 90 degrees. Before we do that, we need to establish something about the sine, cosine, and the tangent. First of all, what you're looking at here are quadrants, and this is just simply the terminal angle here. Remember that whenever you graph an angle, you would go counterclockwise if you're going in the positive direction, or clockwise if you're going in the negative direction. The quadrants are numbered. So this is quadrant 1, 2, 3, and 4, and that's in the spirit of how you would rotate angles. Remember, starting from this position, you would go this way, and as you cycle through all the quadrants, we number them accordingly. Now for these quadrants, you should note that in quadrant 1, all the trigonometric functions are positive. That's the sine, the cosine, the tangent, and their reciprocals. But in quadrant 2, only the sine is positive. Here, just the tangent is positive. In quadrant 4, just the cosine is positive. If you remember that, that's going to be critical for you to get your solutions to any sine, cosine, tangent problem that goes beyond 90 degrees. By the way, this also goes for their reciprocals. That's the cosecant, the cotangent, and the secant. The key to doing these problems requires you to understand the reference angle, so how about we do a problem and then we'll go into it. Let's first start off with this. Determine the reference angle of 110 degrees. Let's first just sketch that angle. If we go to 110 degrees, that's of course more than 90. So a little bit past that, and we're just going to kind of rough it here as far as where it is. So we're guessing somewhere around here. Now, since the angle is more than 90 degrees, what we're going to need here is a reference angle. A reference angle is an angle that is adjacent to the x-axis, and it's always between 0 and 90. So what we're talking about here is the angle right there. You see, the reference angle is an angle that we refer to as part of a table. In reference to a table, every angle can be linked to an acute angle. So if you were doing, say, like the sine or the cosine of 110 degrees, you would need only to look up 70. In any case, this one only asks for the reference angle, so 70 is our answer, and that's it. Alright, how about we try a second one? Let's determine the cosine of 193 degrees to the nearest thousandth, and we'll do this without a calculator. Let's again kind of draw out 193 degrees. That's of course more than 180, which is halfway around a circle, so a little bit beyond that, and again we're just kind of guesstimating about how far 193 is, but we definitely know that it is in this quadrant. So how about that reference angle? The reference angle, remember, is adjacent to the x-axis. So in this case, we're talking right here at this location. How many degrees is that? So we're not talking about here. Don't get into the idea that it's always whatever's left over to get to the next axis. It's always what's next to the x-axis, so sometimes you might get an overlap. In any case, you should recognize that that's 13 degrees because we went past 180, subtract that from 193. So this is what it means. What it means is that if we were going to look in a table, we would be looking for the cosine of 13 degrees because the answer is going to be pretty much the same. In a table such as this, it only goes up to 90 degrees, and the reason why is because once you surpass 90 degrees, all these values start to repeat, and the only difference is that sometimes the answers may be positive or negative, which we'll get to shortly. But in any case, we know we're looking up 13 degrees. That means for us, in the cosine column, we're looking at this value here. So 0.9744 is our solution, and that's almost it. The only thing you have to determine now is whether or not this answer is supposed to be positive or negative. Again, all the answers are the same, but the only difference is the fluctuation between positives and negatives. So this is where we go back to this. All of them are positive here, sine here, tangent here, and cosine here. Well, here, just the tangent is positive, and 193 degrees wound up in this quadrant. Since this is not a tangent, that means that this is supposed to be negative. So that's our answer. How about we try another, only this time without the table. Let's determine the exact value of the tangent of 300 degrees, no decimals. And because it says no decimals, that's telling you that we wouldn't be using that table that we used a second ago. However, it does mean that we'll be using the table that we generated early on, namely this one. Let's again map out 300 degrees, which takes us past 90, past 180. If you add another 90, that's 270. So somewhere over here in quadrant 4. The reference angle is right here because, again, it's supposed to be near the x-axis. So that's 60 degrees. So what we do now is we look up 60 degrees in our table, and if we trace that, the tangent at 60 degrees is the square root of 3. So now you're only left with just one thing. Is it positive or negative root 3? Recall that just the cosine is positive in this quadrant, and we're not looking for cosine, we're looking for tangent. So therefore it's negative root 3. So that is our solution. Alright, let's do one more. This time let's determine the cosecant of negative 210. Just as before, we want to map out this angle. That's negative 90. Notice the direction we're going. That's negative 180. Negative 270 takes us here, so that's too far. Therefore, that brings us here in the second quadrant. And the reference angle, remember it's supposed to be adjacent to the x-axis. That's 30 degrees. A reminder that the reference angle is always positive. It's always between 0 and 90, and if you're wondering why, it's because it's in reference to our tables. Our tables don't have negative values. They're all positive. And that has to do with triangles. In triangles, we don't typically have negative angles. So the negative here in this case only points to the direction in which we mapped out our original angle. But as far as we're concerned, this is all that matters, 30. So that's what we're really going for, and the only question is whether the answer is going to be positive or negative in the end. Keep in mind that all of them are positive here, but just the sign here. But remember that the sign has a reciprocal, the cosecant. Whatever is true for the sign is also true for the cosecant. So since the sign is positive in this quadrant, the cosecant will also be positive. So now let's go have a look at that table. At 30 degrees, the sine is 1/2. So if we were asked for the sine, 1/2 would be our answer. But since it's the cosecant, all we need really is the reciprocal of 1/2. That means our answer is 2. And that's all there is to reference angles. Just remember how to create that chart like we did in the early part of this video. And then if you remember the whole thing about positives and negatives, that all are positive here, just the sine here, just the tangent here, and just the cosine here, you can get the sine, cosine, or tangent of any angle out there in the universe. If you're having trouble remembering this, in other words, which one goes where, then just remember this little sentence. That all students take calculus. All are positive in this first quadrant, just the sine in the second, just the tangent in the third, and just the cosine in the fourth. Just remember which way in which we go about this. It goes in the order of the quadrants. So if you remember how they're numbered, you remember them because that's based on how we would graph any particular positive angle. So all students take calculus. That's all are positive, sine, tangent, cosine.